Hello everyone, welcome back to the Data Structures and Algorithms series. Today we will learn about what are arrays. Simply, an array is a collection of elements stored in contiguous memory locations, accessed using an index. You guys can think of it as a row of boxes that contains a value. So you guys can see these boxes, each one of them has in numbers 1, 2, 3, 4. Now it could be anything within those boxes. Here's an example of how they're represented in a few different programming languages. So here's array 1. In Python and JavaScript, it's represented in square brackets and each numbers are separated by commas. And in C and C++, it's represented using curly braces. So you can see John, Alice, and Bob inside of the array. You guys can think of arrays as lists as well, or fixed-sized lists. Here's a real-world analogy of arrays, guys. So number 1, a row of mailboxes. As you guys can see, each one of them is numbered and indexed. You can see 0, 1, 2, 3 underneath each one of these boxes. And the mailbox A and mailbox B and so on is essentially the value that the box stores. Right, so you can think of mailbox A as a label, or you can also think of it as the actual value that is inside of the array. The key idea here, guys, is you can directly access any mailbox just by knowing the number. And these numbers, guys, are essentially known as the index. So 0, 1, 2, 3, right? So if we access it using the index 0, then we will get mailbox A. If we access mailbox C, then we use index 2 and we'll get the value, which will be mailbox C. Number 2, here's another example, a list of favorite book names. So we have a list of book name 1, book name 2, book name 3, and so on. And here's another one, a list of items in a shopping cart. So we have bread, eggs, flour, and chicken inside of the array or list. Here are the key properties of arrays, guys. So in most languages like C, C++, and Java, arrays are fixed sized, so they can only contain a specific number of elements or items. It's fast access, right? So like accessing an item at a particular index is O of 1 time or constant time. It's stored in memory back to back. So if you guys look right here, where we have our definition, we have 1, 2, 3, 4, and each item follows one another. See, 1, 2, 3, 4. Alright, so here is a time complexity table for arrays. So we have the operation for access by index, and its time complexity would be constant time. So if we access, for example, let's look at our mailbox B. Since we know the index is 1, we can access it instantly. So it's constant time, O of 1. Search in an unsorted array is another operation that would take O of n time, because we must check each element, meaning we have to go through each element one by one in order to find it. Insertion at the end of an array, it's O of 1 time complexity. And it's also a constant time if there is only if there is space, right? Insertion, middle or start of the array. So the time complexity would be O of n, because elements must be shifted in order to make room for the element that we want to add or insert within our array. Deletion at the end of our array, it would be O of 1 time complexity, because we're just removing the last element. Deletion in the middle or the start, O of n, because we have to shift the remaining elements. Alright guys, so here are the use cases for arrays. Storing the scores, for example, the scores of students, or just records of or a database of basketball scores, guys. That's another example. Managing a list of users, keeping track of items in a cart. So let's say you're on Amazon and you click the add to cart button. You're essentially adding those items into an array. So here's what you guys just learned. You learned about arrays. In the next video, we will learn about linked lists. So, and make sure you hit the like and subscribe button, and I'll see you guys in the next video.